Section 3.3 notes, properties of functions and the difference quotient, page 4. So let's look at this mathematically. By the picture, far left, we know that this function is increasing because as we read it from left to right, our function values, our y values, are going up. And so let's take a look at what that means in terms of the mathematical statement. So for a less than b in some interval I, that just means that a is smaller than b, f of a is less than f of b. And that means that f is increasing. In terms of what we're saying in the coordinates, as x gets bigger, y gets bigger. And that's all that means. For that middle graph, we got for a less than b again, but this time the order is reversed. F of a is greater than f of b. This is an example of our decreasing function. This says as x gets bigger, y gets smaller. And the last one on the far right, you notice here we don't have any order for a and b. For all a and b in I, f of a equals f of b. That just means for any a and b, for any x's in the interval, the y's are the same. I don't really know if I need that apostrophe there, but it just makes me feel better. Example 7 takes a look at a couple of different things that are easily confused. So we're going to see if we can differentiate here and make sense of this. So we want graphs where, using the graphs we used for example 6, that was the previous page, okay? We want the interval where the graph is increasing. So again, we said it was increasing as we read left to right from negative infinity to negative 2.7, and then also from 1.4 to infinity. So we've got negative infinity to negative 2.7 and 1.4 to infinity. Remember, parentheses there, we do not include that max and min because we definitely don't want to say it's both increasing and decreasing at the same point. Second part here, where is our function decreasing? As we read left to right, we've got this spot right here in the middle where our function's going down. So negative 2.7 to 1.4. Again, parentheses there. I can't have that endpoint in one interval but not the other, in the increasing but not the decreasing. So it just gets left out of both. So C, do we have a maximum or minimum in that interval? So we are talking about the separate intervals for increasing or decreasing. So I'm going to change these to those intervals. And that's a no, because we don't include the endpoints. That was weird. So we don't have a maximum or minimum value there. D and E, now these get confused with the increasing and decreasing. Where is the graph positive? That means y is greater than 0. So I want to know where our y values lie above the x-axis. So we're going to go dark green here for positive, and this is positive on this part. And then over here. So we're looking for where the y values are positive. And so we've got -4 to -1. Again, this is positive. We don't include the 0. 0 is not officially positive, nor is it negative. Union, another way to fancy way to write and. And then we've got, where are we? 3 to infinity. And where is our graph negative? Anywhere that our y value lies below the x-axis is going to be our negative y values. So we got y less than 0. Again, we are not including 0 because 0 is not negative. And that is our negative infinity to -4 and -1 to +3. So everywhere our y values lie below the x-axis, our y's are negative. So we have some of our parent functions here. The identity for linear equations, f of x equal x, just the basic equation of a line. Where is it increasing? That is increasing everywhere and decreasing nowhere. Our absolute value function, increasing to the right of 0 and decreasing to the left of 0. Our square root function, only defined, and this is our parent function, we haven't transformed it, we haven't moved it around, only defined from 0 to infinity. So it's increasing everywhere there, except for at the point 0. Again, we don't include that when we talk increasing, decreasing. This is decreasing nowhere. Our quadratic function is increasing to the right of 0, decreasing to the left. Our cubic function, even though we got that little wiggle in the middle and it's easy to look at 0 and go left and say it's going down, no, this is increasing everywhere. Again, we read this left to right. Our reciprocal function, keep in mind we're reading left to right. So as we go left to right, decreasing. As we go left to right, decreasing. So this is not increasing anywhere. It's decreasing from negative infinity to 0 and then 0 to positive infinity. Again, we cannot include the 0. That's an asymptote. It is not part of the domain, so it cannot be part of the intervals where we're discussing increasing and decreasing.